On to question 2. We are determining the maximum and least principal stresses compared to all of these different angles. So these are going to be the equations that we gave you on your handout. So it's going to be this guy and this guy. So we're going to figure out our normal stress and our shear stress. We are told that a homogeneous rock body is measured at 125 kilobars and 0.8 kilobars respectively. Thinking back to how we measure our differential stress, right? These are the units that we're using. So before we've been using megapascals, now we're using kilobars. So here we have our graph. So we have our sigma s, our sigma n. We're going to label this going by 0.2, 0.4, 0.6, 0.8, 1.2, 1.4, 0.6, and 1.8. So our minimum principal stress, which is our sigma 3, is going to be our 0.8. Our maximum, our sigma 1, is going to be 1.5. If you take the difference, add 0.8 plus 1.5 divided by 2, you're going to get 1.15. So this gives us the center of our circle. We then take our compass and draw our circle. So there's my very weak circle, but there's a circle nonetheless. And this is plotting up our stress circle. So then we are going to take our protractor, put it on the center of our circle, and we're going to be entering in our radius. But these angles, remember, we're doing 2 theta. So this is the measured theta. We actually end up doing 2 theta. So 2 of 25 is 50. 2 of 45 is 90. 2 of 60 is 120. 2 of 65 is 130. And 2 of 80 is 160. We then take those and we're going to plot those on our circle. Here and here. Now you can graphically calculate this out, or you can enter it in on the equations here. Remember our sigma 1, we write it out, sigma 1 is our 1.5 kilobar. Our sigma 3 is our 0.8 kilobar. And you can plug it into those equations and get your appropriate answers. Doing that will give you a normal stress here of 1.37 kilobar, about 0.27 kilobar, 1.15 kilobar, and 0.35 kilobar, 0.98, 0.30, 0.93, 0.27, 0.82, and 0.12. Now, just in case you need to know how to enter that inside your calculator, right, we're going to follow our equation here. So we've got sigma 1, 1.5, plus sigma 3, 0.8. Then we divide that by 2. So that's our, we're going to write it down over here, 1.5 0.15. That's our first part of our equation for sigma n. That was this part. Then we have sigma 1 minus sigma 3, so 1.5 minus 0.8 divided by 2. And that gives us 0.35. And we take 0.35 times cosine of 50, right? So that is our first 25 degrees. 0.35 cosine of 50. And then we add our 1.15, and that gives us our 1.37, which we wrote down here. And then our shear stress, we just have sigma 1, 1.5, minus sigma 3, minus 0.8, divided by 2, and that gives us 0.35, and then we multiply that by 0.35 times the sine of 50, sine of 2 theta. I gotta enter it right. 0.35 times the sine of 50, and that gives us our 0.27, which is what we wrote down here. So you can figure it out graphically. These guys all match up. You can figure it out using the equation. Ultimately, these guys should have matched up, and that is how you do question 2.